Question 1. 987 plus 100. So we have 900s and we're adding 100. So our answer is 1087 because that's 10 hundredths, and then the 87 stays the same because we're not adding any tens or units. Question 2. 46 plus 304. If we ignore the 300s for a moment, we have 46 and we're adding 4, so that's 50, which means that our answer is 350, because we added to make 50 and the 300s in our question stays the same. For these early questions, it's best to solve them mentally if we can, because that will save us time. But we could have used column addition. 4 plus 6 is 10, so 1, 0. 1 plus 0 plus 4 is 5, and 3 plus nothing is 3. Question 3. 326 divided by 1. Any number divided by 1 is just that number, so our answer is 326. Question 4. 468 minus 9. The easiest way to subtract 9 is to use adjusting to subtract 10 and then add 1. If we subtract 10, we get 458, but subtracting 10 means we've subtracted 1 too many, so we need to adjust by adding 1 to what we got, and that gives us our answer of 459. The other way to subtract a single-digit number is to subtract so you get to the previous multiple of 10, so subtracting 8 gets us to 460. Then, if we've subtracted 8 and we need to subtract 9, we need to subtract 1 more, and that gets us our answer. Question 5. Something equals 936 plus 285. Well, it doesn't matter whether the equal sign is at the start or at the end. We do the same thing. We can set this out as a column addition. 6 plus 5 is 11, so 1, 1. 1 plus 3 plus 8 is 12, so 1, 2. And 1 plus 9 plus 2 is 12. So our answer is 1221. Question 6. 95 divided by 5. We can set this out as a short division. 9 divided by 5 is 1 remainder 4, and 45 divided by 5 is 9. So our answer is 19. Question 7. 89,994 plus 7,643. Now it doesn't look like it at first, but it's possible to solve this question mentally if we notice that 89,994 is 6 less than 90,000. So if we add 7,643 to 90,000, we get 97,643. But that's 6 too many, because this first number in our question is 6 less than what we added. So we need to adjust by subtracting 6. We can do this mentally, because 43 take away 6 is 37. So our answer is 96,637. So that's how to solve this question mentally. But if we're unsure, we can always use column addition. 4 plus 3 is 7. 9 plus 4 is 13, so 1, 3. 1 plus 9 plus 6 is 16, so 1, 6. 1 plus 9 plus 7 is 17, so 1, 7. And 1 plus 8 is 9, so that gives us our answer. Question 8. Something equals 435 minus 30. Well, again, it doesn't matter whether the equal sign is at the start or at the end. We do the same thing. So we need to work out 435 minus 30. We can do this mentally because we have 3 tens and we're subtracting 3 tens. So really, we're just taking the tens away from 435, which means that our answer is 405. Question 9. 96 divided by 4. We can set this out as a short division. 9 divided by 4 is 2, remainder 1, and 16 divided by 4 is 4. So our answer is 24. Question 10. 879 times 3. We can set this out as a column multiplication. 9 times 3 is 27, so 2, 7. 7 times 3 is 21, plus 2 is 23, so 2, 3. And 8 times 3 is 24, plus 2 is 26. So our answer is 2,637. Question 11. 71 times 8. We can set this out as a column multiplication. 1 times 8 is 8, and 7 times 8 is 56. So our answer is 568. Notice that there was no regrouping in this question, so we might have been able to save time by solving it mentally. Question 12. 50 times 70. We know that 5 times 7 is 35, so our answer is 3,500, because if we have 2 end zeros in a multiplication question, we need 2 end zeros in the answer. So we just multiply the 5 and 7, then count the zeros. Question 13. 100 times 412. Our answer is 41,200, because if we have 2 end zeros in the question, we need 2 end zeros in the answer. To multiply a whole number by 100, we just put 2 zeros on the end. Question 14. 3.005 plus 6.12. Now, if we look at the units, tenths and hundredths of both numbers, we can see that there won't be any regrouping. 3 plus 6 is 9, and then because we don't have any tenths or hundredths in our first number, we'll have the 1/10 and 2/100ths that we added in our answer. So our answer is 9.125, because we've added our units, tenths and hundredths, and then we weren't adding any thousandths, so the 5 in our thousandths stays the same. But we can always use column addition if we're unsure. So we have our decimal points lined up, which means that all of the place values in our question will be lined up as well. Now we can write a 0 in our empty place value column, and so we don't forget, let's copy the decimal point down into our answer straight away. Now 5 plus 0 is 5, 0 plus 2 is 2, 0 plus 1 is 1, and 3 plus 6 is 9, so we have our answer. Question 15. 486 divided by 3. We can set this out as a short division. 4 divided by 3 is 1 remainder 1, 18 divided by 3 is 6, and 6 divided by 3 is 2. So our answer is 162. Question 16. 15.98 plus 23.314. We can set this out as a column addition, making sure that our decimal points are lined up. Then we can write a 0 in this empty square and copy the decimal point down into our answer. Now 0 plus 4 is 4, 8 plus 1 is 9, 9 plus 3 is 12, so 1, 2, 1 plus 5 plus 6 is 12, so 1, 2, and 1 plus 1 plus 2 is 4. So our answer is 42.294. Question 17. 125.48 minus 72.3. We can set this out as a column subtraction, making sure that our decimal points are lined up. We can write a 0 in this empty square and copy the decimal point down into our answer. Now 8 minus 0 is 8, 4 minus 3 is 1, 5 minus 2 is 3, and 12 minus 7 is 5. So our answer is 53.18. Question 18. 122,456 minus 11,999. Now it might not look like it at first, but it's possible to solve this question mentally if we notice that 11,999 is 1 less than 12,000. So if we subtract 12,000 from 122,456, we can see that we have 2 10,000s, and we're taking away 1 10,000, and we have 2 thousands, and we're taking away 2 thousands. So we get 110,456, and you can see how we've subtracted using our knowledge of place value. But that's not our answer, because we've subtracted 12,000 rather than 11,999. So we subtracted 1 too many, so we need to adjust by adding 1, which means that our answer is 110,457. So it's quicker to use adjusting for this question, but if we didn't spot that we could do that, column subtraction would still work. We can't do 6 minus 9, so we exchange, and 16 minus 9 is 7. We can't do 4 minus 9, so we exchange, and 14 minus 9 is 5. We can't do 3 minus 9, so we exchange, and 13 minus 9 is 4. 1 minus 1 is 0, 2 minus 1 is 1, and 1 minus nothing is 1, so we have our answer. Question 19. 3 squared plus 10. So this squared symbol, this small 2, means multiply the number by itself. So 3 squared means 3 times 3, which is 9. If we add 10 to that, we get our answer 19. Question 20. 0.9 divided by 10. So there's an easy way to divide by 10, and here's what we do. We write the dividend, the number we're dividing, then we write a decimal point underneath the decimal point. Now with 10, we have 1 0, so the digits are moving one place, and we're dividing, so the digits are moving one place to the right. So we can take this 9 and copy it down one square to the right. Then we need zeros in our other place value columns, so our answer is 0.09. Question 21. 4 minus 1.15. So we can set this out as a column subtraction, making sure that we have our place values lined up, so with the one whole we're taking away underneath the 4. Now 4 is the same as 4.00, because you can always put a decimal point and then zeros on the end of a whole number. And so that we don't forget, let's copy the decimal point down into our answer. Now we can't do 0 take away 5, and we can't exchange with the tenths, so we need to go all the way over to the units and exchange 1 unit for 10 tenths, and now we can exchange 1/10 for 10 hundredths. Now 10 minus 5 is 5, 9 minus 1 is 8, and 3 minus 1 is 2. So our answer is 2.85. We could also solve this mentally by counting up from 1.15. If we add 0.85, that takes us to 2, then adding another 2 takes us to 4. So if we add what we've added, we get our answer 2.85. Question 22. 1,320 divided by 12. So we should know that 132 divided by 12 is 11. So our answer is 110, because after we've worked out 132 divided by 12, if we can see one end zero in the dividend, there will be one end zero in the answer. We could also use short division. 13 divided by 12 is 1 remainder 1, 12 divided by 12 is 1, and 0 divided by 12 is 0. So we have our answer. Question 23. 71 times 46. 1 times 6 is 6, and 7 times 6 is 42. Now we can write a 0 in our second answer line. 1 times 4 is 4, and 7 times 4 is 28. Now we can add up our answer lines. 6 plus 0 is 6, 2 plus 4 is 6, 4 plus 8 is 12, so 1, 2, and 1 plus 2 is 3. So our answer is 3,266. Question 24. 4 sevenths plus 5 sevenths. We have fractions with the same denominator, and we know that when we add fractions with the same denominator, the denominator stays the same. Now 4 plus 5 is 9, so our answer is 9 sevenths. We could change that into a mixed number, but in this paper we still get the mark if we leave it as an improper fraction, so let's move on. Question 25. Find 20% of 1,800. We know that a percentage is just a fraction over 100, and we can find a fraction of a number by dividing by the denominator, then multiplying by the numerator. So let's start by dividing 1,800 by 100. That's 18, because we can cancel our end zeros, and 18 divided by 1 is 18. Now we need to multiply that by the numerator. 18 times 20 is 360. Because 18 times 2 is 36, then if we have one end zero in our multiplication question, we need one end zero in our answer. So 20% of 1,800 is 360. And here, if we couldn't work out 18 times 2 mentally, we could have used column multiplication. 8 times 2 is 16, so 1, 6. And 1 times 2 is 2, plus 1 is 3. But a quicker method might have been to realise that we'll get the same answer with any fraction equivalent to 20 hundredths. And we can simplify that to 1/5 by dividing both the numerator and the denominator by 20. Then, to find our answer, we just need to divide by 5. Question 26. 15 times 6.1. We can set this out as a column multiplication. Because we have one decimal place in our question, we know that there will be one decimal place in our answer, so we can write in the decimal point straight away. Now, 1 times 5 is 5, and 6 times 5 is 30. Now we can write a 0 in our second answer line, and 1 times 1 is 1, 6 times 1 is 6, so now we just need to add up our answer lines. 5 plus 0 is 5, 0 plus 1 is 1, and 3 plus 6 is 9, so our answer is 91.5. Question 27. 3/10 minus 1/20. To be able to subtract fractions, we need the denominators to be the same, so we can find the equivalent fraction to 3/10 with a denominator of 20. 10 times 2 is 20, and 3 times 2 is 6, so instead of 3/10, we can rewrite our question with 6/20. So we have 6/20 minus 1/20. We keep the denominator the same, and 6 minus 1 is 5, so our answer is 5/20. We could simplify that, but in this paper we don't need to simplify to get the mark, so let's move on to the next question. Question 28. 725 divided by 29. So we need to work out our 29 times table. 29 is of course 1 times 29. So if we work out 29 plus 29, that will give us 2 times 29. And if we're adding 29, the easiest way to do that is to add 30, then subtract 1. So 29 plus 30 is 59, take away 1 is 58, so that's 2 times 29. From 58, if we add 30, we get 88, then we take away 1 to get 87 for 3 times. Add 30 is 117, take away 1 is 116 for 4 times. Then add 30 is 146, take away 1 is 145 for 5 times. And we can be confident that we haven't made any mistakes, because remember, 5 times always ends in a 5 or 0, and that's what we have with 145. Now before we go any further, let's look back to our question. If we take the first 2 digits together, we have 72 divided by 29. 72 is larger than 58, but smaller than 87. So we can write 58 under the 72, And because 58 is 2 times 29, we can write 2 in our answer line. Now we subtract. We can't do 2 minus 8, so we exchange. And 12 minus 8 is 4. 6 minus 5 is 1. And we can bring down the 5, so we have 145 divided by 29. We can see that 5 times 29 is 145. So we have 5 as the final digit of our answer, which is 25. Question 29. 15% times 440. Well, times and of mean the same thing, so we shouldn't let the way the question is written confuse us. What we really need to do here is find 15% of 440. We know that a percentage is really a fraction over 100, and to find a fraction of a number, we can start by dividing by the denominator. So we can start with 440 divided by 100. That's 4.4, because remember, we really have a decimal point at the end of a whole number, and to divide by 100, the digits move 2 places to the right. And if we copy 440 down 2 places to the right, we have 4.40. But we can ignore a 0 on the end of a decimal number and write our answer as 4.4. Now we need to multiply by the numerator, so we need to multiply 4.4 by 15. Remember, if there is 1 decimal place in the question, there will be 1 decimal place in the answer, so we can write in our decimal point straight away. Now 4 times 5 is 20, so 20, and 4 times 5 is 20, plus 2 is 22. Now we can cross out our working, write a 0 in our second answer line, and 4 times 1 is 4, 4 times 1 is 4, so we can add up our totals to get 66.0 or 66 as our answer. But there is another slightly quicker method here. We can work out 10% by dividing by 10, so that gives us 44, and then 5% must be half of 10%, so 5% must be 22. So if we add 10% and 5% of a number, that will give us 15%, and we can see that we get the same answer. Question 30. 6,574 times 31. 4 times 1 is 4, 7 times 1 is 7, 5 times 1 is 5, and 6 times 1 is 6. Now we can write a 0 in our second answer line. 4 times 3 is 12, so 1, 2. 7 times 3 is 21, plus 1 is 22, so 2, 2. 5 times 3 is 15, plus 2 is 17, so 1, 7. And 6 times 3 is 18, plus 1 is 19. Now, if we add up our answer lines, 4 plus 0 is 4, 7 plus 2 is 9, 5 plus 2 is 7, 6 plus 7 is 13, so 1, 3, 1 plus 9 is 10, so 1, 0, and 1 plus 1 is 2. So our answer is 203,794. Question 31. 1 4/5 plus 3/10. So to add fractions, we need the denominators to be the same. So we can start by finding an equivalent fraction to 4/5 with a denominator of 10. 5 times 2 is 10, and 4 times 2 is 8. So instead of 1 and 4/5, we can rewrite our question as 1 and 8/10 plus 3/10. 8/10 plus 3/10 is 11/10. So we still have our 1 whole, but we need to add 11/10. We can't write 1 and 11/10 as our answer because we can't have an improper fraction in a mixed number. But we can change 11/10 to a mixed number. That's 1 and 1/10. And if we have 1 plus 1 and a 10th, we get our answer 2 and 1/10. But there is another way to answer questions like this. That's to change our mixed number to an improper fraction. As a mixed number, 1 and 4/5 is 9/5, and we need to add 3/10 to that. To add fractions, we need the denominators to be the same, so we need to find an equivalent fraction to 9/5 with a denominator of 10. 5 times 2 is 10, and 9 times 2 is 18. So instead of 9/5, we can rewrite our question again, this time as 18/10 plus 3/10. So we know that when adding fractions, we keep the denominator the same, and 18 plus 3 is 21. So our answer is 21 over 10. Now we could change that into a mixed number, but in this paper we still get the mark for an improper fraction, so let's move on. Question 32. 1118 divided by 43. So we need to work out our 43 times table. 43 is 1 times 43. If we add another 43, we get 86, so that's 2 times 43. Adding another 43, we get 129, so that's 3 times. Now, before we go any further, let's look back to our question. There's no point taking the first 2 digits together, because 11 is less than 43. But if we take the first 3 digits together, we have 111 divided by 43. We can see that 111 is more than 86, but less than 129. So we can write 86 under 111, and because that's 2 times 43, we can write 2 in our answer line. Now we need to subtract. We can't do 1 minus 6, so we exchange. And 11 minus 6 is 5. Now we have 0 minus 8, but if we look across, we really have 10 minus 8, so that's 2. So if we bring down the 8, we now need to solve 258 divided by 43. Now we know that 129 is 3 times, so you might already be able to work out or estimate the answer to 258 divided by 43. But if we're unsure, we can just continue adding 43. 9 plus 3 is 12, so 1, 2, and I've written the 1 in red only so that it's easier for you to see. 1 plus 2 plus 4 is 7, and 1 plus nothing is 1, so that's 4 times. Adding another 43, we get 215 for 5 times, then another 43, takes us to 258 for 6 times. So 258 divided by 43 is 6. So that's the final digit of our answer line. So our answer is 26. Now I mentioned that there was a shortcut for 258 divided by 43. Remember, at that point, we'd already worked out that 3 times was 129. So we didn't need to work out 4 times or 5 times. We could have worked out 6 times straight away by doubling our answer to 3 times. If we know that 3 times is 129, then we can add another 129 to work out 6 times, because 6 is double 3. You can see that when we work that out, we get the answer to 6 times 43. So, especially with these later questions, when you might be running out of time, it's always useful to try to spot shortcuts. Question 33. 3/5 divided by 3. To divide a fraction by a whole number, we don't actually need to do any division at all. Instead, we just take the fraction and multiply the denominator by the number. And because 5 times 3 is 15, and the numerator stays the same, our answer is 3/15. We could simplify that, but in this paper, we don't need to simplify our answer to get the mark. So let's move on to the next question. Question 34. 2/5 times 140. Remember, times and of mean the same thing. So here, we're really finding 2/5 of 140. And we can find a fraction of a number by dividing by the denominator, then multiplying by the numerator. So let's start with 140 divided by 5. 14 divided by 5 is 2 remainder 4, and 40 divided by 5 is 8. Now we need to multiply by the numerator, so we need to work out 28 times 2. 8 times 2 is 16, so 6. And 2 times 2 is 4, plus 1 is 5. So 2/5 of 140 is 56. The other way we could have solved this would be to do it the other way round. Multiply by the numerator, then divide by the denominator. So we could have started with 2 times 140, which is 280. Then we could have divided that by our denominator. 28 divided by 5 is 5 remainder 3, and 30 divided by 5 is 6, so we get the same answer. Question 35. 1 1/4 minus 1/3. So to subtract fractions, we need a common denominator. 12 is in both the 4 and 3 times tables, so we can find equivalent fractions to 1/4 and 1/3 with a denominator of 12. 4 times 3 is 12, and 1 times 3 is 3. 3 times 4 is 12, and 1 times 4 is 4. So we can rewrite our question. Instead of 1 1/4, we can write 1 3/12, and instead of 1/3, we can write 4/12. But we have a problem here. We can't take 4/12 away from 3/12. But we can write 1 3/12 as an improper fraction. That's 15/12. And if we have 15 twelfths minus 4 twelfths, that gives us our answer 11 twelfths. But there is another way to solve questions like this. That's to change the mixed number to an improper fraction straight away. 1 1/4 is 5/4 as an improper fraction, and we're subtracting 1/3 from that. To subtract fractions, we need the denominators to be the same, and 12 is in both the 4 times table and the 3 times table, so let's find our equivalent fractions. 4 times 3 is 12, and 5 times 3 is 15. 3 times 4 is 12, and 1 times 4 is 4, so we can rewrite our question again as 15 twelfths minus 4 twelfths. We know that we keep the denominator the same, and 15 minus 4 is 11, so our answer is 11 twelfths. Question 36. 60 minus 42 divided by 6. So here we have mixed operations, so it's really important that we remember the order of operations. We always deal with brackets first, and then we do multiplication and division before we do addition and subtraction. The way I remember this is that addition and subtraction are easy, and we leave the easy stuff to the end. So here we need to do the division first. 42 divided by 6 is 7, so we can rewrite our question as 60 minus 7, which is 53.